What's going on YouTube? This is Ipsec. I'm doing Perfection from HackTheBox, which starts out with hacking a web application that calculates weighted grades. The vulnerability here is like a SSTI. I don't know if it exactly is server-side template injection, but it behaves very much like one. However, the trick is there is some type of filter in place that blocks a lot of characters from being sent. However, if you send a line break, then that bypasses the regular expression that is looking for bad characters. In this case, it's actually a whitelist. But if you send the line break, then you can send any character you want. You can trigger some code execution, get a shell on the box. And then once you get on the box, there is a piece of mail that talks about the password format. And you have to extract the password hash out of a SQLite database and then use a custom rule in hashcat to brute force the password. So with that being said, let's just jump in. As always, I'm going to start off with an nmap, so -sc for default scripts, sv, enumerate versions, -vv, double verbose. This gives us the TTL, OA, output all formats, put in the nmap directory and call it perfection, then 10.10.11.253 is the IP address. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and the banner tells us it's an Ubuntu server. We also have HTTP on port 80. The banner tells us it's Nginx. The HTTP title tells us it's a weighted grade calculator. There's not much in the nmap, so let's just go take a look at the website. So going to 10.10.11.253, we get the weighted grade calculator. Looking at it, there's not that much information. We see made by secure tools, but the thing that really sticks out to me is WebRick version 1.7.0. Whenever I have something like this and it like discloses what it's made by, I always go and look for exploits. I'm going to check out exploit.db. I know you can use searchblade on your box, but I still like going to the web page. And looking at this, I see the dates of like 2008, 2010, 2011. This may look like it's vulnerable because it's Ruby 1.9.1, and it said WebRick 170. I'm guessing this is the version of Ruby itself. Whenever I'm confused like this, I always Google like WebRick 170. Let's do like release notes and see when this was released. Because maybe it's the version of the Ruby like language itself instead of the library. And we see 170 was released in 2020, and all these exploits are well before that. So we could go Google looking for things. Maybe it's not on exploit.db, but let's just go keep taking a look at the website, right? So we go to About Us. We have some names. We have Tina Smith and Susan Miller, but I don't see a login form, so I can't really like start trying for default credentials or things like that. If we go to calculate weighted grade, we have this form, right? So I'm just going to try to fill this out. Let's do a grade of 1, weight of 20, and see what happens here. We need to fill out all the things. That's going to be annoying. Let's do ASD 1. Okay, so I'm going to go into Burp Suite to intercept this so we can easily replay this if we want to, and click Submit. And we see, please re-enter. Weights do not add up to 100. So we have to make sure all the weights go up to 100. I'm just going to replay this request so we don't waste 20 seconds typing it over again. I'm going to send the request, and I want to see where that error message is, right? So we have it right here. I'm going to search the page for /form. Go to the little gear icon, auto scroll when text changes. So now we don't have to keep scrolling to see it. So let's make sure our weights add up to 100. So I'm just going to put all the weights at 20. And because there's 5, so 20 times 5 is going to be 100. Send it, and we see our total grade is 7%. So what I want to do here is, let's see, if I change this to be a 20, we have 10%. So let's try 1 times 20. And we have malicious input blocked. So there is some type of filter here. We can try it in the category as well. Let's do like 7 times 7. And this is just a common like server-side template injection, the 2 double brackets. We have malicious input blocked. And I don't even know if this works in Ruby. I'm assuming this is a Ruby because we saw powered by WebRick 170. Oh, and there's the Ruby version, 302. So that's disclosed in the header as well. Going back, exploit.db is closed, but we know there's no vulnerability in the Ruby language itself because we didn't have anything there, and WebRick. So let's see. What can we do here? I want to see all the bad characters. So what I'm going to do, get a valid request, And then I'm going to copy this to a file. So we're going to right click and then copy to file. And we're going to type, let's see, weighted.request. Save that. And then let's just take a look at it. And I'm going to put fuzz where I want to fuzz. So we're going to go in category, just put fuzz in all capitals. And now we want to find a word list that is special characters. Let's do fuzzing. Let's see. Is there a special? I'm just going to grep-i special. There we go. So we have this special characters.txt. Okay. I think I only copied the file name. Let's copy the entire path. Copy. There we go. Awesome. So now we can do FFUF. I'm going to say -request, and we called it weighted.request. I'm going to specify the proto is HTTP, and then the word list I want to use is this seclist one. And then we're going to send it. And I'm guessing everything with 1619 is a bad character, right? That's probably going to be malicious detected, right? So we can say filter size 1619. And we have 3 that are valid. And the 3 that are valid is only valid because it's probably not URL encoding these, right? It's just sending like the ampersand, which if you send this and don't URL encode it, it does nothing, right? Because it's going to treat that as a separator. So like this, if we go here, like it doesn't show the ampersand here where it's replaying the data, right? Same with the plus, that's just going to put, oh, the space did go through. So space looks like it is a valid character. We could try a slash, and looks like slash is valid. If we wanted to, we could URL encode all this pretty easily. If we do echo slash, and then we pipe this over to JQ. So I'm going to do JQ dash capital R. This is going to like not require it to be JSON. It's just read raw input, I think. And then lowercase r is going to be raw output. But if we don't do the lowercase r, it just puts it in those quotes, right? That's how we want this to look. And if we don't do a capital R, it errors. So what we're going to do is cat the file. So if I do a cat this, and now we URL encoded that entire payload, right? So I'm just going to go up here where my FFUF request was. And then if you go with a, I think that's less than, and then the parenthesis, it's going to run this command and then treat it as a file. So this is a quick way to just manipulate your files or do like encoders, because I don't think FFUF supports encoders. wfuzz does, but I don't think FFUF does. So we throw this, and I'm going to get rid of the filter size. That doesn't look like it worked, actually. Let's see. Why did that not work? That is odd. If I run this command, did I screw it up? I don't think I did. Oh, we don't have a cat. We have to run the command, right? We have to cat that file. There we go. Okay, so filter size 1619. And the only thing that's good is %2f, which is a slash. I'm actually surprised the plus didn't get work. If we do a plus, and then URL encode this. Yeah, it does not work. So what I'm guessing here is space is a valid character, but plus is not, right? So when the regex was seeing it, it did not like the plus. If we just send it without URL encoding it, it's not really sending plus, it's sending space. So that's probably the discrepancy there. So there is one thing that is hard to test through burp, just because if you like highlight, you can't really convert this. It is new line characters. So like \r \n, that's really %0d %0a. If we do man ASCII, let's see, look for return. Where is it? Carriage return 0d, and then new line is 0a. So let's try that. Let's do %0d, %0a, and then I'm going to put a semicolon, which is a bad character. And we still have malicious input blocked. If I just do a new line, it actually worked. We have ASD and then a semicolon. So we have successfully bypassed the filter. And why does this work? I don't know exactly because we haven't looked at the code, but it does generally work when like there's a regular expression. And the regular expression is not multi-line. It's just going to look at the first line, it passes that, and then it moves on to the next one because they didn't specify, like if it's python.all is normally how it happens, I think, because period won't match a line break unless you have the .all parameter. This is Ruby. I don't know much Ruby, so I don't know exactly what the issue is here. Once we get a shell, we can take a look at it, right? But doing a new line allows us to bypass the filter. So let's go ahead and look up Ruby SSTI payloads. So now that we can test this, and let's see, I like going to payload all the things and hack tricks. And it's loading probably because Burp Suite is still in intercept. Nope, it's not. It's just taking its sweet time. I'm going to turn this off. Maybe. My VM's actually going slow. Wow, that is going real slow. Disable. You can see something spiked here. Let's search for Ruby. And then we have % equals %. Okay. So let's go back to repeater. And then after the 0a, we're going to do like this. And then 7 times 7% like that. And we have some error. I'm guessing we have to URL encode this. So % is %25. And there we go. We have 49. If this had 7 times 7, we know it wouldn't be vulnerable. But since it actually processed this, it is. So let's take a look at what they suggest. We could do like file open. We could also do system. So I'm going to try this system payload. So if we grab this and then we send that, let's just go hit enter. We just get true. So it's not reading the output. The result of that command was true, like the exit code. If the file doesn't exist, we get false. We could try the other way they said it. Let's just leave the cat etsy passwd. Instead of doing system, let's just do backticks. Right? Like that. And then we get the output. The other thing it had was like IO, popen, ls. This also works to get output as well because you're reading the lines. If you do system.readLines, it doesn't work. I don't know Ruby. I don't know exactly why, but these two payloads would be the best to get results. If for some reason I didn't have access to those payloads, I would probably try a sleep command or a ping, because if we do a sleep 1, it takes now a second to load. We can do a sleep 2, look at the bottom right of the screen, see 2000 milliseconds, so we know it took 2 seconds to load. So let's now just get a reverse shell. So I'm going to do, let's actually make shell on a box. And the reason why I'm doing it this way is, if I can type and talk at the same time, that'd be great. We're in something that could have like a lot of bad characters. So if I do it this way, I can avoid all the bad characters by just doing base 64. And bad characters, I just mean like quotes and things like that. So I always like using a cradle like this just because there's less bad characters. The one thing you have to be careful on when doing base 64, we'll have to make sure we URL encode the payload, because that plus is going to be treated as a space and not how we want it, right? So let's do a echo, then base 64-d, then bash. Okay. URL encode, nclvnp 9001, send this, and we get a shell. So let's upgrade our shell. So I'm going to do python 3-c, import pty spawn bin bash. And then control Z, sdty raw minus echo, and then foreground, hit enter twice. And then we can export. Man, I cannot type today. Term is equal to x term, so we can clear the screen. And now let's take a look at what we have. And the first thing I generally look for is some type of credentials stored in the web app, like it talks to a database normally. However, I don't believe there's a database behind this web app. But the one thing I am curious about is um, how that SSTI worked, right? How we bypassed the filter. So I'm just going to look at main.rb. And let's see, this is looking at a post on weighted grade calc. So I think it's right where we want to be. And we're looking at this and we see else if params category 1. And then we have this regular expression. So this is matching A to Z, lowercase, uppercase, 0 through 9, and a space. And then matching as long as it starts with and ends with that string up until a line break. So the %0d, that is a return character. And I guess return is not part of this line break in Linux, only \n is, right? So that's why when we had the return, it doesn't match. And, we also match slash. I don't know if I said that. So there's no really bad characters. It's a whitelist, not a blacklist or a deny list. And then we get code execution Y. So we're just checking here. I don't see anything there. Oh, it's doing an erb.new. And then we're just passing in our parameters. Think of like erb.new as like an eval because it's just like embedded Ruby. So it's just doing a script. And whenever you do the less than %equals, it's executing. So I don't know if this is technically SSTI or not. Maybe it is. Maybe erb.new is like for templates and things like that. But that's why you get code execution, because you can think of this as eval, I guess. So let's see, what do we have here? If we look at our user, we can see we are a member of sudo. So if I do sudo-l, it wants a password for Susan. So let's see, what do we have? We have user.text. We have this migration thing. If I cat, let's actually do SQLite. Do we have it? Yep. Pupil.dump. And then we have a bunch of hashes. Let's see, we can do echo-n, wc-c. We have 64 characters. Is that like a SHA-1 sum? Echo test SHA-1. Let's do awk print 1. So we only grab the first character. That's probably too small. wc-c, 41. Probably SHA-256 sum, I would think. Yep, there we go. It says 65, not 64, because there's a line break in there. I bet if I did echo-n, that did not work. Yeah, so it did that just because of the line break. So let's see. We have to figure out what Susan's password is. I'm just going to do a find on the box to see what files Susan is a owner of. So I'm going to do find /-user Susan. Let's see. We can also add a ls. And then let's hide error messages because there's going to be a lot of files we can't open. And let's see. We have a lot of things in own. I'm going to hide everything in proc because I don't care about proc. I forgot the -v. So let's see. We have home Susan. And that is about it. So we just have things in the home. Let's take a look at the group. So we'll do group Susan. And let's see, we have a bit more. So she owns that Ruby app. And then there's also a piece of mail. So let's take a look at this. So I can cat var mail Susan, and we see due to a transition to Jupyter grades because of the pupil path data breach, we should migrate our credentials. And we have the format, first name, then the first name backwards, and then a randomly generated integer between 1 and, is that 1 billion? So my question right now is, how do they do this? Because that could be like 1, or you could do, let's see, like this. So I don't know how it's formatted. I'm going to guess it's form of 10 digits, but I'm not positive. So we have to go over, first we have to extract all the credentials out of this pupil path database, and then we can go over to the Kraken and try cracking it. So let's do that. In order to get all the table names, I'm just going to run that dump command again, and I want to extract the name and password. Actually, our user is Susan, so we could probably just do it with Susan's hash, but I'm going to extract all the hashes just because, right? So we're going to run that SQLite command again, and then I'm going to do select name password from users, and that is ugly since it did that line wrapping, but we have it there. If we wanted to, we could do stty-a rows 28 columns 110, stty rows 28 col 110. Is it cols? There we go. So now if I did that SQLite command again, we can do select name password from, was it users? Yep. There we go. So fixing the TTY just means I can go all the way left and right. So it just behaves a bit better. Now for hashcat, when you specify usernames, does like it delimited in a semicolon. So we could just do a sed s pipe semicolon g like that. And now we have it in hashcat format. But what I want to do is just grab Susan's. So I'm just going to grab this. We're just going to work with Susan to see if we can get her password real quick. So let's go over to the Kraken, cd hashcat, and then I'm going to go in hashes, and we can call this perfection. And I'm just going to paste that. And now let's take a look at the man page for hashcat, because we're actually going to use a attack mode here. And we normally don't use attack modes in hashcat because we're just cracking off a dictionary, but we want to manipulate something. So we got the modes, we got the straight, this is the one we normally use, but I'm going to use the brute force. You could also use like the wordlist and mask. That's going to like combine the brute force with the mask. So if you wanted to have a word list of multiple names, you could. I tried doing a lot of that, but I couldn't get a rule file to do what I wanted to, because we have to do the username, then an underscore, then the username backwards, right? And I tried a long time. Let's see if I can remember this real quick. Let's just do echo ipsec, and then we can say /hashcat, is it std out, and then -j for a rule. So if I just do -j, I want to append a underscore, right? So this is how I was playing around with rules. So I could get that working. And then F is reflect the word backwards. But every time I did that, I had this underscore here. And I couldn't figure out for the life of me how I can reflect the word and delete a character, right? The bracket is delete the first character, so I was hoping that would delete the reflected character. If you're curious all this, if we Google like hashcat, probably rules will bring us to the page we want, rule-based attack. So we can see how a lot of the rules works here, right? So that's where I was getting it from. But all these rules like either require knowing the position, and there's no way I could figure out how to get the length of a word's position. This whole memorize functionality looked helpful, but if we look at the plus note, it indicates it's in hashcat legacy, not the new one. So I couldn't like memorize a word then replay it. Maybe someone in the comments can help me, but I just couldn't figure out how I could get it in the format I wanted to with just a rule file. So I resorted to the brute force because we can specify characters here, right? So let's do hashcat, and then we'll do attack mode 3. And then let's go into hashes perfection. And then we can say Susan underscore Nassus underscore, and then it was a billion. So I'm going to do 9 digits. So 1, 2, 3, 1, 2, 3, 1, 2, 3. That should be 9 digits. And then if we run this, it's probably going to tell us we match multiple hashes. We want to use mode 1400 because it's just a SHA-256. I guess, I don't know what SHA-3 256 is, but here we go. It is going to start running. And let's see, how long does it expect to take? Oh, it's already done. So we got recovered 1 out of 1. That was like near instant. I think if we switch to attack mode 6, for some reason, it goes a lot slower. So we see that took 15 seconds on my computer. I can do, let's try going to attack mode 6. So we'll call this combinator dict, I guess, or I misspelled that. I'm going to do Susan, Nassus like that. Actually, let's get the word list real quick. Let's see. What did it crack? // hashcat bin 1400 hashes perfection show. So here's the password. Let's just see if this works real quick. And then I'm going to go look at hashcat. So if we do a sudo -l, paste in the password, looks like we can sudo. So I'm going to do sudo su. And now we're root, right? So I just want to show why I did not switch to attack mode 6. So we got that combinator dict file. So if we did this correctly, let's see, we should be able to do mode 6 like that. And then we specify like this, right? We want to remove the pot file, hashcat pot file. There we go. So we'll see how long this takes. I don't think it's going to take just 15 seconds. I don't know why doing it this way is slower, but it is. Or maybe we just got lucky how it hit the digits. That is also very, very possible. So I'm just going to let this run, and we're going to run it twice to see if it's the same on combinator, right? Because there's only one word, I think it's only going to use one of my GPUs. I don't know if it did that before, but I'm going to pause the video and we'll see how long this one takes. I know I said we'd let this crack finish, but it's been a couple minutes and I am only like 8% of the way through. So I'm going to kill this. I'm going to look at the speed. We're at 274,000 hashes a second on one GPU with the combinator mode. We're going to run what we did before with, let's see, what is it? This right here. And see what speed this goes. So 274,000 hashes a second. We'll see how quick this is. Wow. A lot faster, right? This is like exponentially. So we didn't just get lucky. Using attack mode 6 with just one word in the word list makes it go really slow. The brute force mode with one word makes it go a lot quicker. I'm just guessing it's like less processing when it does it this way. I'm not exactly sure where all that IO is coming from. But as you can see, if you use the combinator mode, you need to have a pretty big word list. I'm actually kind of curious if we duplicated this a bunch, if it goes any quicker. Probably not, because it's probably going to use the same number each time. But it may use more GPUs. We got to move that pot file again. Let's see. How quick is this? So at least we still only just use one GPU. So that does not speed it up any. So yeah, if you do this and you just have one word, you could use combinator, it works, but definitely use the brute force mode when you can over combinator because it's quicker, or at least hybrid wordless combinator. So with that being said, that is the video. Hope you guys enjoyed it. Take care, and I'll see you all next time.